Hello everyone. So today we will study in detail about Ethernet frames. So first comes is the preamble. Preamble in an Ethernet frame is like a wake-up call for the devices on a network. It is a series of special bits that signal the state, that signal the start of a data transmission. Think of it as a way for devices to say, "Hey, pay attention. I am about to send some data." It helps the receiving device sync up with the incoming data and prepare to receive it properly. Once the preamble is done, the actual data flows. So, in simple terms, the Ethernet preamble is like a friendly knock on the door to get in to get a network conversation started. So the second comes is start frame delimiter, which we also call as SFD. In an Ethernet frame is like the second part of the wake up call after the preamble. It's a specific pattern of bits that tells the receiving device, okay, get ready, get ready to listen carefully because the actual data is coming right after this. It helps the receiver recognize the beginning of the data portion of the frame. So in simple terms, the SFD is like the door opening after the friendly knock of the preamble, indicating that the real conversation, data transmission, is about to begin on the network. In an Ethernet frame, the destination MAC means media access control, address and source MAC address are used to identify the source and destination devices on a local network. Here is what they mean. Destination MAC is the MAC address of the device to which the Ethernet frame is being sent. It's like the mailing address on an envelope, specifying where the frame should be delivered. The network switches uses this address to determine which devices on the network should receive the data. Source MAC address on the device means it is the MAC address of the device that sent the Ethernet frame. It's like the return address on an envelope, indicating who sent the data. This helps the receiving device know who the sender is and can be used for communication or troubleshooting. These MAC addresses are unique identifiers assigned to network interface cards (NICs) in devices like computers and routers. They are essential for ensuring that data is sent to the correct destination on a local network. The 802.1q header in an Ethernet frame is like a tag or label added to the frame to help network switches understand where the frame should go in a more complex network setup. Imagine it as a sticky note on an envelope. So let's break down the .q header. First comes TPID. Inside this TPID, the TPID stands for Tag Protocol Identifier. It's like a special marker at the beginning of the 802.1q header telling network devices, hey, I am using a specific tagging system here. Imagine you are sending different types of parcel and you want to use colored stickers on to label them. The TPID is like a label on the box that says, I'm using the green sticker system. It is a way for network equipment to know how to interpret the rest of the 802.1q tagging information correctly. So in essence, TPID is just a little piece of information that helps network devices understand the tagging system being used for the data in the Ethernet frame, making sure it's handled correctly as it travels through the network. The TPID value 0x8100 is indeed used for single tagging in Ethernet frame. It indicates that the frame contains one layer of Vlan tagging using the 802.1q standard. This single tag helps identify the VLAN to which the data belongs within a network. So when you encounter the TPID value 0x8100, you can expect that it's associated with single VLAN tagging. Then the PCP, priority code point, inside the 802.1q header is like a traffic signal for Ethernet frame. It's a 3-bit field that assigns a priority level to the frame data. So the priority level, the ranges of PCP is from 0 to 7, with 0 being the lowest priority and 7 being the highest. Think of it as assigning a priority to different types of vehicle on road. emergency vehicle get the highest priority, while regular cars might have lower priority. PCB also used for quality of service. PCB helps manage the quality of service for data and network. Frames with higher PCB values are treated with higher urgency, ensuring that critical data gets through more quickly. Then comes drop eligible indicator. The DEI is a field inside the 802.1q header, and it's used for prioritizing and managing network traffic, especially in situations where some frames can be dropped during congestion to ensure the smooth flow of more critical data. Then comes a VLAN, virtual local area network. The VLAN are like separate virtual networks within a physical network used to keep different types of traffic isolated. So this header tells the network switch which virtual department the data should be sent to. With 12-bit, you can represent up to 4096 different VLANs, because 2 raised to power 12 is equal to 4096. Then comes EtherType. EtherType is like a label on the envelope that tells the recipient what's inside. It helps the computer receiving the data know how to handle it. For example, it might say, hey, this is a web page or this is a video. It's like a little note that helps the computer network understand what to do with the data they receive. The EtherType values a specific number in the Ethernet frame header that tells the receiving computer how to interpret the data inside the frame. For example, if the EtherType value is 0x0800, it typically means the data is an IPv4 packet like internet traffic. If it's 0x0806, it could be an address resolution protocol packet used for mapping IP addresses to MAC address. Value can also indicate other protocol custom data types. These values are in hexadecimal format and help computer identify the type of data contained in the Ethernet frame. In the Ethernet frame, the payload is like the actual content of a message or package you send in the mail. It's a data you want to transmit over the network. This could be anything from a web page, a video file, a text document, or any other type of information. CRC, cyclic redundancy check, in an Ethernet is like a digital fingerprint that helps ensure the data sent over the network is accurate. It's a way to detect errors in the data. Imagine you're sending a message to a friend and you want to make sure it arrives without any mistake. You could add up all the numbers in your message and send the result along with the message. When your friend receives the message, they can also add up the numbers. If their result matches the one you send, they can be pretty sure the message arrived intact. In Ethernet, CRC works similarly. The sender calculates a special number based on the data in the frame and adds it to the frame. When the receiver gets the frame, it also calculates this special number. If the receiver calculation matches the one in the frame, it knows the data is likely error free. If they don't match, it suggests there might be an error, and the receiver may request the sender to resend the data. So CRC in Ethernet frame helps ensure that the data you send over the network is not corrupted during transmission, kind of like a digital checksum. Thank you. Hello everyone. So today we will study in detail about